guys, welcome back. It's Kaushik here. Today we are going to discuss about the data structure and algorithm in Java on linked list. So let's see what linked list is. Linked list is a sequence of links that contains elements. Each link contains a connection to another link. Linked list is the second most used data structure after arrays. Following are the basic operations supported by a list: insertion, display, search, and delete. So these are the some of the basic operations which we can deal with a list or a linked list. So this is one of the variation of a linked list. We call it a singly linked list. In this kind of data structure, each data element is having the reference of the next element. As you can see here, the first element is called as the head, which is linked with the next element, and the next element again contains the reference of the next element to it, and it continues and so on. And the last element won't have any won't hold any reference of the next element, so it would be null over here, as you can see. So this is all about singly linked list, and this is the descriptive diagram, the architecture of a singly linked list. Now let's see how we can create a singly linked list data structure programmatically. Let us create a class and name it as mm, singly linked list. That's it. Our class is ready now. Now let us create a inner class node. This inner class is actually the objects whenever we are passing any element inside our list, and these are the nodes which are linked with each other, and those nodes are represented as an inner class over here, and we are having a private variable called element, and we are also holding the next element. And now let us generate the getter and setter methods for these two variables. Select all. Okay, here we go. Now our node element is ready. Now let us create the private variable of this node element and name it as head. And let us create another variable of integer data type. Okay. And this variable is actually this will actually hold the size of the linked list, our singly linked list. Size is ready. Now let's create another variable, capacity. So we are actually designing a linked list which is elastic in nature, which will expand whenever we are adding more elements into it. So we don't have to predefine our size. So by default we are making it as 100, the capacity of this list, and let us create a method to auto expand it. So whenever we are reaching to the point, elastic point, At that time we are going to expand our list. So this is the method. And here we are going to put the validation. If capacity minus size is less than 5, we are going to expand it. Okay, let me add the return type over here. It is a void method. So now in this scope we are actually expanding it by let's say 100. No, make it 20. So whenever the list size will be less than the capacity, and the difference between the capacity and the size is going to be less than 5, means if it is 95, sorry, 96, at that time we are going to expand our capacity to 20. So whenever it reaches 96, our actual size will be 120, sorry. So now we are creating the add method, which will accept the parameter of element, means the generic element t. And before adding any element, we will be calling this expand list method. Now excuse me. Now let us store the head variable inside some temp variable, the class level head variable, into a local method variable, and we will do a check over here. It's equal to null. Then we are going to create, actually we will be by default head is null, so we are going to initialize it as a new object. And we are going to set this element data into the head element. That's it. And if it is not null, okay, I forgot to increment this size, so here we have incremented the size. And actually our purpose is, if it is the first element, then we are incrementing the size. And now we have to break this loop also, so it's broken here. Now let's check if the next element is null. Now what happens if the next element is null? It means uh, the property of singly linked list is the last element is going to be null. So whenever we are adding any data, it has to be attached, means we are going to attach it to the last element. So first we are doing a null check of the next element. If it is null, that means it is the last element, and whatever new data which we are passing as the parameter of this add method is going to be added in that next element. means the place where it was null. So we are going to create a node. That's it. Now we have to set this data as a element of this node, and we have added this node element into our temp, as you can see here. That's it. Now let us increment the size of this array, our sorry, the list, and break it. Now there is one more condition. Let's suppose the next element is not empty. So what we are going to do is we will be looping further, means let us assign this temp with the next element of the temp, and it will continue, means it will start iterating from the beginning, and it will keep on means it keeps on iterating until it reaches the until it reaches the last element. That's it. Now let's check the list which we have created is proper or not. So this is the main method, and I have created an object of simply linked list, and we are going to store integers over here. So let's store some integers. Let's run it and check. Okay, now the problem is we are adding the elements into the array, but we are not traversing it, so that's why it is not printed in the console. Now let's create a method to traverse through this list. So before traversing, we are doing a size check. If size is equal to 0, the size of this list, then actually we will be printing a message: list is empty. Else, while true, now let's store the head element into the uh, local variable. Let's name it as temp. In the else case, we will be assigning the temp variable with the next element. Now let's call this traverse method in our main method and check it is traversing through this list or not. Let's run it. The elements which we have out inserted 22, 4, 54, 7, 31, and it is in the same sequence printed in the console. So our add method and our traverse method are working properly now. Now let's go further by creating one more method. It would be for fetching the data from our list from with uh, by passing the index as a parameter. We named it as get. So we did a check over here for excuse me. So the check is written that the index should not be greater than the size of the our list. So if it is larger than the size, we are throwing an array index out of bound exception. Okay, seems good. Now let's write the else case. So in this actually we are creating a count. So keep to keep our index in track, and here we are going to compare like if our count the value of our count is equal to the value of the index, then actually we are going to fetch the value. So here let's print the value get element, and in the other case we are going to assign the temp variable with the next element. So this is our else case. Okay, it was my mistake. Instead of get next, I have written as a get element. Now we are going to break our loop in the if case. Now let's our main method and see if it is fetching the element by index properly or not. So let's fetch the second, that is 54, the second index. Oh, uh, some null pointer exception. What happened? Okay, here, let's do over here. Okay, the count is proper here. Okay, this is the issue. I forgot to increment the count. So now let's increment it. Now let's run the program. See, it's proper here. It's printing 54 after a blank line. 54 is the actually the index which we are retrieving. So it was 54 over here. So now let's write one more function to remove the element from the list. Let it be void method and we will name it as remove, and we will pass the index of the element which we are supposed to remove. This is it. Here also we will be doing a check. If the index is greater than the size, we are supposed to throw an exception. Most probably, uh, array index out of exception would be a proper in this scenario. So let's throw the exception. This is it. Now we will write the else case. In the else case, we will be storing the head element in a temp variable. Now let's create a counter. Now we will loop through our data structure which we have created, and we will remove the element from the index. So here we are comparing the index with the count. If it is equal, we will be writing the logic for removing the element from the index. Now we have created a variable of node, and we will be storing the next element of the temp, which is the element which we are supposed to delete, which we are supposed to remove. Now let's type temp, and from the temp we will set the element next to uh, the element which we are storing for variable n. So set element, sorry, set next, and here we are going to store n dot get next. This is it. From this you can see the element which we are deleting from our data structure. uh, Here what we did is we have stored the parent element of the element which we are deleting, and we have linked it with the next element of the yet to be deleted element, and in this way we are completely detaching the indexed element. Now in the else case, we will be assigning the uh, next element, means get next, to the temp, and here it's good to go. And we will be of course we will be incrementing the count, and I am not going to repeat the same mistake which I did for the get method. Now let's verify our remove method is working properly or not. Now let's try to remove the third index, and after removing we will traverse our our list, our data structure, to verify that the element is completely removed or not. So let's type linked list dot traverse. Now let's execute it. Yes, everything goes well. Now you can see we have removed this 7, which was actually 0, 1, 2, 3, third element. And after removing it, we are traversing the list. And in this also you can see the 7 number was removed from our list. So this is all about singly linked list. And I will be sharing this code in my Git repository, and you can get this link from the comment. And thank you guys. Thanks for watching the video, and stay tuned for my next video. Thanks.